All right, we are now up to, this is chapter 7, number 62. Okay, so here's the situation. Let's draw a picture over here. We have something pulled by a cord, a cable, and so it has the tension force. You could write F sub T if you want. Just put an arrow on top of it when doing the free body diagram to indicate that it's a vector and not a scalar. There's also the force of gravity. So, all right, there we go. All right. So, the direction it's moving is up. So let's just indicate that. Good. Now let's figure out what we know. We know that the mass is 265 kilograms. Okay. And we know that the displacement that it goes 23 meters. Okay. The acceleration is given as 0.15 times of gravity times gravity. Okay. 0.15 times gravity. And gravity we know is 9 point. Let's wait for this to catch up. Here it goes. 9.80 meters per second squared. All right. So, part A is asking for the force of tension, saying, what the heck is a force of tension? So, that's the first part. All right, there we go. And then part B is asking, what is the net work done? Part C is what is the work done by the cable? And part D asks, what is the work done by gravity? Part E asks, what is the final velocity if its initial velocity is 0? Okay. So, let's start with A. In order to find A, we take the sum of all the work, actually all the forces in the y direction. So that's the sum of all the forces direction. Well, that would be tension force minus the force of gravity, the weight of the object. And all that equals ma. There is an exception. However, we know specifically that the acceleration is so instead of putting ma, you put m0. They give us the acceleration at 0.15 0 times gravity. Okay. All right. Now the force of tension we can solve by saying it's m times 0.150. Let's catch that up here. 150 g plus mg. So that equals 1.150 mg. Okay. So, knowing that, we can plug in the numbers. We have 1.150. We have the mass, which is 265 kilograms. And we have 9.8. We can put 9.80, just in keeping with the second figures. This is meters per second squared. Oh, I think I am using the computer's abilities, the max of them. Okay, so that comes to 298 86.55 newtons, which, using sig figs, significant figures, is 2.99. Here's a times 10 to the 10 to the newtons. Okay. So that part A, 2.99 times 10 to the 3 newtons. That's the force of tension.